famous guy on TPOT. He's 20 NN so far, but not more. Already shaping how people think about RL and beyond.
I feel like I've lacked like really persistent direction in terms of what I want to do. Get into a feedback loop where it's like I'm building upon what I did before. And once you find your footing, you start to go from like that shallow, oh, this would be interesting to work on, like immediate curiosity, to a very focused, a very concentrated, and a very powerful curiosity. What makes these systems valuable versus what makes them, interesting. And I think that's an important thing to distinguish between, because what I think people get out whenever they say research taste, like it's not about having a really good idea. It's like being capable of selecting the way better idea from a pool of a bunch of things that you could do. Is this a failure of the idea? Is this a failure of the execution? Which idea is actually the best given best execution? You go, why does Will swim so majestically? And then I look and like, he's right. The dude's a majestic swimmer. Like, if he wasn't doing machine learning, maybe he'd be doing this, Or it's like liminal. You don't know which direction to pursue, but like eventually one of those random walks, you're gonna start like staying on your 2 feet.
Hello, ladies and gentlemen. Welcome back to Ground Zero AI Talks. So today on Ground Zero, we are going deep into the lore of Kalomaze, the famous guy on TPOT. He's 20 NN so far, but not more, and already shaping how people think about RL and beyond. So I guess this is going to be fun. So we are going to dig into the lore, how he got here, what drives his experiment, and his views on where AI is really heading. Before we dive in, a quick note on Ground Zero is all about. So we do a lot of foundational stuffs here, and really unpack how people at the frontier are thinking about intelligence, reinforcement learning, and AI research. We have had conversations with folks like Will Brown, Token Vendor, Daniel Han, and today it's time to hear Carlo's story. So let's straight jump in. Hey, Carlo, how are you?
Good. How are you?
Good. I guess this is your first time camera appearance.
Yep.
I really things go well. Yeah.
Yeah, I've definitely been, on this for a hot minute. I've gotten a lot more just organic influence just through posting, and I guess targeting these insights, these like kind of niche insights that a lot of people might take for granted, might not necessarily see immediately. Like they'll see the situation at a service level, and they'll get like the gist down, but there might be some like precise in detail. I like to think of that one image where it's like there's like this huge structure where it's like pointing to this one tiny domino that's like lifting up, what I'm talking about? Like the domino that's like just one tiny thing and it's lifting up the entire rest of that structure.
Pretty interesting. Also, when someone sees your profile, it's written extremely silly Jester. What does it actually mean to the new people you want to talk about? Yeah.
So what does that mean? In my bio?
Yeah. What do actually you mean by writing extremely silly Jester? Yeah.
Extremely silly gesture. Well, the way I like to think of it is like, if you want to carve out a space for yourself on, just any social media, you want to have like your wits with you. You don't want to be like, just always serious all the time guy. You don't want to be like, always joking. Well, it really depends on your personality type and like what you want to do and what you want to put out there. But for me, I've always been the type of person who like, enjoys a bit of, humor, enjoys taking things like, with like a degree of like levity. Like I don't want to position myself as like, a incredibly serious researcher, a serious mode all the time, but more like someone that's like, just more very genuine, so that I guess it sort of builds implicit trust in people's minds whenever you are like yourself.
Okay. Also, people talk about. I guess I've read this comment from you only. Alpha maze isn't the only maze that got alpha, and I guess pretty much we mean it all reading on the teapot. Okay, let's get back to the story. Probably. So, can you talk more about? Basically, take us back to your school days. What kind of kid were you? What were the hobbies or interests that stuck with you back then? And how did that eventually turn out into a path toward machine learning? Yeah.
Honestly, I don't think like if I went back to like even just me like in freshman year and like I told freshman me that I was going to like have a job like this, I don't think you would have believed me, because I've always been, I think, technically minded. I've been like inquisitive and curious, but I feel like I've lacked like really persistent direction in terms of what I want to do and what I really fundamentally like am good at. There's this thing that I think the term for it is like hobby hopping. Like it's associated with like people with ADHD, where it's like kind of bounce between like a bunch of different things. Like I remember I tried like getting really into like 3D art, like Blender, and learning programming as well when I was younger, and like neither of them kind of stuck at the time. Whenever I tried to get into them, whenever I tried to be really good at those things, and looking back at it, I think one of the biggest reasons why that was the case is because like I was just learning these skills that I could have used to build something interesting, but I didn't have like an immediate like context where I could apply those skills and like really get into a feedback loop where it's like I'm building upon what I did before, and I am fundamentally like driven by that signal, that learning signal. And whenever you're just learning like a rote skill independent of the context of where you use that skill, it can feel super disconnecting, right? Because in high school, I feel like I've always been like much more literate in terms of like English and writing and things like that. I sort of taught myself to write, not necessarily like fiction, but like nonfiction, like technical writing, documentation, tutorials. Like that was something that I got good at. I remember as early as like 11 or 12, I wrote these like tutorials. You can still find them, like if you look them up, like Game Banana, like llms or whatever. Is like these Super Smash Bros. Modding guys and like just hacking like Nintendo consoles, like and getting into like the homebrew scene. Something that I've always like been good at from that perspective is like teaching, and I guess what I get out of sharing knowledge is like sort of making certain things that are like that have become obvious to me ubiquitous. That's the type of thing that is really motivating to me, to be able to produce like new knowledge through persistent effort and persistent like dedication. And I think the reason why machine learning specifically stuck out after like my hobby, like years where I was doing hobbyist stuff primarily for like modding video games and getting really good at technical documentation in the process of doing so, just because I wanted to like teach other people, and the fact that I'm able to do that now with machine learning, and that I can execute in like a tight feedback loop and learn something from these experiences that transfers that other people can use, that makes me more competent and makes me more capable, makes it very like fundamentally rewarding. And I think that's how I landed up where I'm at right now.
Quite interesting. I'm curious, when you say about you were into programming from your school days, what kind of system you were more into building? Like it's kind of some game or machine learning system or some.
I feel like it started as like game development, because it's like just it's like the immediate thing that sticks out, especially when like you're young. Like there's a lot of people who like really are talented and can execute in that, but I think for some people it's like they have like the mixture of oh, I like video games, oh, I'm good at like technical things, so I should work on video games for like a living, but like in my case, I think the pivot was like natural, because I sort of had this weird intuition that I didn't really want to do like a technology job, like that people were sort of pigeonholing me, like, oh, this kid's going to be talented at like whatever he decides to get good at, because I was like concerned that I was going to end up doing something that I didn't really click with, that didn't really register with me. And I guess a part of like why I was sort of all over the place and trying different things and trying to get like really good at specific hobbies and interests is that like I sort of lacked direction, but I had a lot of general curiosity. I once heard it articulated as like when you're younger, the curiosity that you have, as a child, or as like even like an early teenager, is like you have like really wide curiosity, and it goes like in all sorts of directions, but it's shallow, right? It's not very deep. It doesn't cut very far. It doesn't really get to the really rich intricacies of a particular domain. But as you get older and as you find a niche, and you sort of like, at first it's just like sort of like a random walk. You're learning to like walk for the first time in this direction for that particular thing that you're interested in. And once you find your footing, you start to go from like that shallow, oh, this would be interesting to work on, like immediate curiosity, to a very focused, a very concentrated, and a very powerful curiosity, something that runs deep. And that depth is important to preserve, because there's only so much that you can do as an individual. And if you really want to make an impact in something, you have to stick to something. You need to be, disciplined about like what you choose to pursue in that discipline, and not just like, oh, this could be cool, this could be interesting. You have to become discerning. You have to become, for better or worse, maybe a little bit like what's the word for this? It's not like too aggressive. I want to go with hostile, so I'm just going to go with it. Like you have to become like hostile to some ideas that just don't work or won't work for whatever reason, that people are not saying out loud, or just have never felt the need to articulate, because they have never been like as committed to improving in a particular discipline. And I think that's a part of what I think people get out whenever they say research taste. Like it's not about having a really good idea. It's like being capable of selecting the way better idea from a pool of a bunch of things that you could do. And some of those things are not necessarily bad ideas outright. They're not necessarily bad research directions. Like, and that's a very black and white and narrow way to view it. If you were going to view it that way, like, oh, this research direction is completely worthless. Like, it's rare that I will feel that strongly about something that I think is not that useful or beneficial. It's just you have to be selective and you have to be careful about what you work on if you want your development to push you in a direction that gets you the results that would be like maximally useful for your development as like a researcher or as an engineer. And part of where this comes from is I've the bit of reading of like Steve Jobs and what he had going on, where he repeatedly emphasizes like this core principle where you need to select for one particular like thing that is the most useful in a situation that's going to get you the farthest, and you have to become very disciplined about this. And sometimes it'll involve like things that you want to do that you think are interesting, that have their own utility, that are just not as useful as doing the something that might be more obvious but more beneficial, or something that is a little bit more annoying to do but is going to help you in the long run. It's not going to like accumulate tech debt because you're having to handle a bunch of things that could have been more elegantly covered by a more unified approach. And this is the type of thing that you only really develop with like experience and very fast iteration cycles where you can meaningfully absorb what about that failure made it fail, and determining like which failures are like, is this a failure of the idea? Is this a failure of the execution? Which idea is actually the best given best execution? Things like that.
Nice. This is, I guess, beyond what we have expected. But yeah, I'm also curious about since you have dropped college right now, like, do you ever plan to go to bachelor's or more higher degrees right now?
I don't think I'm going to pursue a degree, at least not for the foreseeable future. I think I'm fairly comfortable where I'm at, and I feel like I'm learning a lot more through practical work experience where I'm at right now than if I was to, major in computer science for a few years. Because, like, especially for the domain that I'm working in right now, it's not something that you necessarily can take a course on. It's something that it's a discipline where a lot of the knowledge is kind of implicit. It's not really stated outright. You're not going to find a lot of it on our archive on any flashy papers. A lot of it's not flashy. A lot of it's not marketable. A lot of it is stuff that is kind of a little bit grueling. I don't want to say like super grueling, but like there are little things that will screw you over that you have to be very attentive to, that you learn through experience that you can't get from a research paper.
I guess current age of AI research is a lot more about the number of experiment and trials you run in your dorm. And I guess the conventional courses or the researchers or the professors, like this AI research area is pretty much new for all. So I guess you are pretty much at a position that given the experiments you're doing, that would be like the only thing that is required for the future as well.
Yeah, I mean, like right now, getting experience in the types of things that are being developed is like, I feel like in some ways, it puts you in a better position, like in terms of job security, than a traditional computer science path, depending on what you're doing. I mean, I could see some fields and some subfields of computer science taking a long time to like thoroughly automate, or like the shape of the problem that they're trying to solve is like just really, really difficult to like contextualize and like put in like a feedback loop where like, oh, we can train an agent on this. We can train, an LLM to do this specific thing. Like I think a good example of a subfield that I'm thinking about is reverse engineering, where a lot of the knowledge is very implicit. A lot of it is not outright stated, and especially it requires, I think, like a discipline for understanding the shape of like maybe a particular code base. Like imagine you're trying to reverse engineer some old video game that was written in like C, and it's like PowerPC assembly, and it's like Claude's not they're not putting an LLM to solve these types of problems right now. And I think there's a lot of like subfields that are going to look like that, but there's also a lot of subfields that are going to see a lot of dramatic change and already are seeing change. Like obviously the most immediate applications are like, things that are like Pythonic, where you're trying to orchestrate higher level systems from like lower level primitives. I mean, AI training itself, it's predominantly Python. And the other type of, I guess beyond just immediate software engineering, what is being built right now is going to teach you, I guess, meta skills about what makes these systems valuable versus what makes them, interesting. And I think that's an important thing to distinguish between, because you might have something that's very capable for a lot of really important problems or for some very important niches, but whether or not that can be trusted and reliable end to end with like 99.9% accuracy to like just get that last oomph of performance that like really matters, especially like any domain where like I want to think like cybersecurity. I want to think of things where like you can't really tolerate failure, right? You can't tolerate a little mistake that you can course correct from. I think most programming isn't like that. I feel like most programming, if you're doing it right and you're planning correctly and you're thinking at a high enough level where you are able to accommodate for these like basic pain points, you're going to be fine. Especially with like LM programming, if you're able to just read what it's writing and getting into a productive feedback loop where you're not just trusting it blindly, you're not learning to just ship whatever the first cursor suggestion pops up to prod, then I think that's fine. But there's also domains where it's like I can see why a lot of industries, a lot of knowledge work is going to be skeptical for like years to come, maybe even like 10 years, if I'm being like fairly conservative about like, how fast like companies will adapt to progress. Like we might end up in a situation where we have really, really capable technology that is burdened by like regulatory tape. It's burdened by industry standards and norms that that will take time to adapt, that can't immediately react to this new thing that is capable. I think learning to use these things and productionize them in a way that's not just a gimmick is very possible, but it requires a lot of discipline, a lot of taste, and a lot of understanding of what can go wrong. And the only way to figure that out is through just starting somewhere and learning something from the failures instead of just doing a first iteration and then shipping that or giving up.
That totally makes sense, and the way the current systems are developing, I guess, yeah, this pretty much holds true. What was your parents' reaction when you told them you're quitting degree or the high school, and yeah, how pretty much how did you convince parents basically? Yeah.
Sorry?
What was your parents' reaction when you told about you are quitting bachelor's or high school, you're not continuing it and going to deep dive into research in the company, or pretty much how did you convince them? Yeah.
Oh, well, more specifically, I already graduated high school, I believe, 2023. And I guess, yeah, this was like the gap year where I was like, I wasn't sure what I was going to do or how I was going to productionize myself, in something that, I feel like I could commit to consistently and be disciplined about and like actually good at. I was going to be in UTSA. I was going to enroll in UTSA, majoring in computer science, which did not happen because I got a DM on Reddit from Toby Lutke, the CEO of Shopify, and that basically saved me from like the tuition, from all the baggage that comes with enrolling in a university, and I could sidestep that to like immediately get practical work experience at like a big tech company, like a relatively large company. And I think I did gather like some valuable experience, especially like in terms of working with a team. Yeah, so the story of what happened with Shopify is essentially I started independently experimenting with the resources that I had with like small llama models. I was like messing with like KL divergence losses, if I remember correctly, with someone else. And the Reddit thread that I posted, like just documenting this because I thought it was interesting to like have some write up of some kind of this type of knowledge that most people wouldn't think to share that proactively, ended up coming in handy because I got the job offer from Toby Lutke, CEO of Shopify, and I didn't even know that was like him at first. All I saw was, hey, we're at Shopify. We're interested in like hiring people like you. Have like you have this type of like independent portfolio for machine learning, and we want to bring you on board for an internship position. And I guess how I reacted to this immediately at the time was, I'm going to get a lot more out of a real world work experience probably than if I just, went to university and like got a CS degree. I'm going to be able to learn things about how to like work in a team, which, I'm a lot better at that right now than I was, even just a year ago. And I'm still, learning and improving all the time, of course. But that was the type of experience that I thought was most valuable. And, it looks good as well. Like, this is like a reasonably sized tech company. If I really couldn't find work somehow, like I would be able to have this on a resume. I would be able to present a pretty compelling case for myself based off of independent projects that I've worked on. As for like, how my folks reacted, how my parents reacted is, they thought it was a scam. they thought it was a scam at first, and like they were like, okay, you need to double check everything. You need to make sure that these emails are not fake. You need to make sure that it's not like a phishing link where it's like at like Shopify dot like co or something, or like just take the domain somehow. But no, I vetted this. I made sure that you know the emails that they used were real emails that belonged to the company, and um, they were supportive overall, very positive of it. That's skeptical of whether or not it was like a real offer because it sounds kind of like outlandish on the surface, like hit some CEO of a tech company lurking on Reddit. They directly message some 19-year-olds like, hey, we want to give you a job you're going to work on like vision language models for like our hierarchical classification stuff, and that ended up working out pretty well for me, I would say. And I'm not working there anymore, of course. Ever since I joined Prime Intellect, I think that was March, April-ish. I get a little fuzzy on the precise dates, but I definitely had a lot of other counter offers at the time. By that time, and I was sort of in a indecisive state. I was like at a sort of standstill between, do I want to work somewhere that might like have higher compensation or might not be directly aligned with the things that I want to work on, that is then less like interesting. I can see myself finding a way to specialize for this thing. Or do I want to work somewhere that will give me the freedom to incorporate ideas more fluidly and sort of trust me in terms of planning on what I think is going to be valuable instead of just like executing on like a specific engineering plan. And when it came down to that, I ended up picking up Prime Intellect specifically because it gives me that level of experimentation and I guess research freedom that I see as sort of like a non-negotiable, or like if it is a negotiable, then I'm going to need to be like compensated much more thoroughly in exchange for the freedom that I would be losing. And at Prime Intellect, I like obviously I'm not just like doing whatever comes to mind. I have to do things that are like at least squarely aligned with like the immediate roadmap in terms of what we want to deliver and ship on. But there's still a lot of room in that space of things that are valuable, that are personally interesting to me, that I can like put like 110% of my effort towards. And as well as that, I think like there's like a camaraderie that I have with the team, with other people on the team. Obviously, you can see this just from public communications. Like most of Prime Intellect is at least somewhat active on Twitter, or they at least lurk. But I think we want to foster like a culture that is not going to be too narrow in terms of like immediate goals, and has like the flexibility to like change trajectory as the people at the company see fit. And like as we are right now, we're pretty lean. I mean, we're hiring right now, obviously, but in a team like this, it definitely makes more sense to be adaptable and be fluid than to like be trusted to execute like one specific thing, because the shape of the industry, the AI industry specifically, is that things are changing all the time. What is obvious now might not be the obvious thing to do 6 months from now. And if you want to work on ambitious projects, you have to not lock yourself out of potentially useful and interesting research, but you do have to still find a nice middle ground between, oh, this would be really interesting, this would be really fun to work on, versus this needs to be done by X period of time because we want to see results on this. And we don't want to get like stuck in this like a novelty minima where we are just trying a bunch of different things, but like we're not getting good at like the fundamentals, the essentials of what makes these things valuable and what makes experimenting on top of them reflective of the general use case, of like real use cases. And that's important.
Yeah, and with Shopify Lore comes up, how did Prime Intellect happen to you? Was it something you actively sought out, or more of a story where they found you, how other companies were approaching you back then after Shopify? And what's the backstory of you joining the team behind PI?
So for specifically the Shopify case, whenever I got hired, it was kind of a hectic period because they had like the 20th, like it was the 20th anniversary for the company. And what they do every year is they have like this summit in Toronto in Canada. And at the time they hired me, that was like, I think a month afterwards, or like 2 to 3 weeks. I don't remember the precise details, but all I know is that whenever I checked my passport to make sure that I actually could fly out for this, it turns out that I was going to need to get a new passport. I was going to need to get that expedited, and they were very like open and very like proactive and like, okay, so you can't travel, then we'll just like we'll pay for the expedition costs. We'll pay for making sure that you can fly out on time for that, like for the Shopify summit, and that did indeed happen. It was very hectic because like it was something that. I wasn't really expecting that part of the equation whenever I was doing the first few interviews. Like they had me go through, I think 3 different interviews. Like one of them is like, like culture fit versus like technical backgrounds versus like actually executing on something. And they seem to like, hold me in pretty high regard. Like obviously like Toby specifically like kind of scouted me out and found me. So I guess that also contributed to like how people saw me, because like I remember it was pointed out like that doesn't really happen every day. This is not something that we do regularly. This is something that was kind of spontaneous, and like I guess people really wanted me to like know that, and it definitely makes sense considering that like I didn't even know that was him at first. That was something that had to, like that was pointed out later, like, oh, that was the CEO reaching out to you. So yeah, that was a crazy bit. The summit was I definitely had a lot of fun going out there, especially like because like on my mom's side, she's actually Canadian, so it's not like the first time I've been to the country, but I think it was the first time that I was in Toronto specifically. A funny bit of trivia is I think Drake was supposed to perform. They had like a concert, a private concert where there's like Weezer and the Roots, and I think Drake was supposed to be there but couldn't make it, which is like that was so funny to me because like they just pulled up like on the big screen, like they had a pre-recorded video of like, yo, I can't make it out, or something like that, and like I just kind of got jump scared by that. It was like, what's going on here? It was a lot all at once, basically. Is just what I'm trying to say here. But whenever I left Shopify, I had different offers. I had competing offers. Prime Intellect was one of the ones that they reached out to me because I independently. I think they had a program at one point, or yeah, we still do. For like compute grants for like specific individuals and independent researchers, and I don't think they were all that interested at the time. Actually, ironically, whenever I first joined the server and I started talking to people on the team, but that was like when I was still like early into learning about the stuff. Like I think about a year ago, really, and I started talking to Sam, especially Sammy a lot. Samsha, that's his tag on like Twitter. He has like the One Piece avatar, and at one point, Sam was like. I think we're interested in bringing you on aboard like full time, just based on like, I had a lot of technical discussions with him, like, just without really the motive of like trying to get a job, but it helps to like actually know these people and like have like reasons to like be technically literate and like just getting to know people in the space, even if your motive is not necessarily to get like a job immediately. But yeah, that's besides the point. More back to like how I actually got on board. Like immediately after I left Shopify, they were like, yeah, we can hire you like earlier than expected. I think. The draft for what I read, it was like originally like June, but they were able to like just push that back immediately because I think they were like pretty excited to have me on board, and I appreciate that like big time because it was kind of like unexpected. But it was better than just kind of like being like paralyzed by choice, like analysis paralysis. Like there's a bunch of different companies or organizations that have reached out or messaged me directly somehow that see value in me somehow. So if I want to go somewhere, I want to be somewhere where it's people that I already know, like like good vibes that I'm familiar with, that I see as like competent, not just like on a technical level, but in terms of like understanding what avenues of research are like meaningful to explore, so that for one, that I have confidence that like I'm working with people who I can like depend on, that have like good intuitions, and secondly, that I don't feel like I'm being made to do stuff that's like. It's not that useful, or it's like it's not going to pan out. But like I like the worst scenario for me is like I work somewhere that's like high TC, high compensation, but like I dread it. I dread like something like a job at like a really big like think Google, think Meta, like that size company. Not necessarily like any one of them individually, but like just any giant company where you don't have that freedom. And I landed on Prime Intellect because I felt that they would be able to provide me that freedom, and also that I would be able to build real things as the company progressed.
That's quite tasteful. Also, I'm curious about what's your generic workload at PI on day-to-day basis. Yeah.
Sorry, can you repeat that?
Also, I'm curious about what's your workload on the daily basis at PI?
As for workload, what I'm expected to do, I guess, as of recent, like it sort of depends on like the context of what we're working on at any given time. But like, just like for context of like the last month and the last 2 months, especially, has been a general upkeep on like the infrastructure that we're building. Like Primarel, obviously, there's been a lot of quality of life stuff and a lot of like feature support that I've taken the initiative on or the lead on, and uh, beyond that, though, the expectation is like I'm able to integrate some elements of like a useful an idea that's like interesting and make it useful and make it concrete. Especially on the data side, I think they're putting a lot of trust in me on that, and that's something that I've like been working on for like the environment. So like if you go to, we actually have a new repository for it because we wanted to like segment like the actual trainer, which is like Primarel, from the environments, because verifiers, like that's the dependency that handles the abstractions around environments that Primarel uses for the actual training. But the environments themselves are sort of modular. They're meant to be things that can stand independently and don't have to live in the same scope as a trainer itself, with all the associated baggage for training specifically. So we have the prime environments repository for that now. And if you look there, you'll find things like the sentence unscrambling environment, which is like the problem setup there is you have like originally like an ordered list. It might be something like the order of like the planets in the solar system, like measured by distance. And for the actual verifier, you scramble that data piece that you have in a random order, and the job of the model is, given this like list, what's the correct chronological sequence, and trying to get it to match that sequence as precisely as possible. That's the type of data work that I've been working on. Like I think for that one specifically, I remember using like a smaller model to get like the draft candidates, and then like DeepSeek V3. I think it was actually R1, where I was just like doing rubrics and just like careful LM as a judge to make sure that what I was training on was something where the original sequence order was actually something that was like strictly chronological in a way that wasn't just like arbitrary. But yeah, that's the type of work that I've been working on: data, environments, and general infrastructure.
Quite interesting. Also, next, like this is one of the thing people talk a lot in this space. People know that well, working on verifiers, and given your contribution as well, can you walk us through the lore there? What makes them interesting and how they are used? For example, when you are running GRPO with semi-verifiable reward roles on complex reasoning tasks, what does that actually look like in practice? Yeah.
So for what Will is doing with verifiers, it emerged out of sort of necessity for something that I was working on, which is I feel like that's a story that you hear in a lot of good software development, where it's like these things didn't just come about because of like, oh, I want to work on like meaningful infrastructure. It's like I have a need that I want to address, and then I realize that this is something that like the ecosystem is missing. Like I'm addressing a gap that nobody else is, and I can afford to turn this like pet project into something that is more like meaningful long term. And what you can see verifiers as in this like in the system of like infrastructure that we're working on is like a general set of abstractions for how to like manipulate language models in an environment with multi-turn and tool calling. Like those are like the standout things that Will has always like advertised and like been like vocally in support of. Not just because like it makes sense if you're trying to build agents for these things to be inherently multi-turn and iterative, rather than you have an input and produce correct output. Because the nature of real world software development is never that simple. It's messier. It requires iteration, it requires tracking state over time. It especially involves using external tools to help you solve that particular task. But the idea for verifier specifically, I'm pretty sure he started working. Yeah, he was working on this at Morgan Stanley. And eventually decided that this is something that he would prefer to be working on full time. And Prime Intellect was probably like the perfect fit, honestly, compared to like any other candidate out there. Like probably some honorable mentions, like RC. RC does a lot of great work. Shout outs to them. But I think that what Will is building is meant to be something that like is not just, oh, this is how Primarel handles like our environments. This is like, no, we want to build something that is like standardized in the sense that Hugging Face has kind of organic traction in terms of like safe tensors for like how you actually like distribute model weights and how you distribute trained language models. And what we're building up to with like the environments hub as well is an ecosystem where like these things flourish, not just like dependent on what we're building, but like other people can contribute. But yeah, probably besides the point. How GRPO and semi-verifiable rewards apply to reasoning? Well, it does depend a lot on form factor, right? In terms of what types of outcomes you're going to get from the training that you're doing. R1 specifically, I think it shed light in a very like obvious, unambiguous language, like the shape of the problems that they were dealing with, and like what the correct or like correct quote unquote way to do it was compared to like speculation on like how OpenAI was doing it in terms of like O1 and the speculation before that in terms of like I think what people were still calling O1 like Q star or whatever it was if you remember that saga. But there's a lot of sort of nerd snipes that people fell into, like, oh, they use Monte Carlo tree search and blah 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 blah. But really, it was as simple as having correct specifications for the outcome in a way where the only way to really get better at this is through things that are actually reliably better at achieving the outcome. That doesn't necessarily have to look like a reasoning model with like a giant scratch pad that's like an XML tag that comes before the final output. It can look more like concrete RLVR, which is like reinforcement learning through verifiable rewards, where it can be as simple as like applying a git diff like deterministically and making that reliable. There's a lot of things that you just don't get for free necessarily by fine-tuning a model through like the traditional pipeline in terms of end-to-end accuracy, because when you think about it, that's not what fine-tuning is targeting, right? Fine-tuning is like about aggregate per token performance, not about end-to-end execution of a task or even just end-to-end recreation of what your training data looks like necessarily. But as soon as you have like actual measurable criteria that correspond directly to the things that you're trying to improve, rather than weak proxies of what you're trying to improve, which is kind of what the pitfalls of RLHF as traditionally applied were, which is not necessarily that like you don't want to use reward models in like reinforcement learning. It's more like this thing by itself is not sufficient for robustness and reliability guarantees. But the nature of what makes a verifiable reward useful to train on is like if this is something that has like real concrete metrics that you can tie it back to that are not just like fuzzy approximations of downstream performance, but like directly correspond to the actual accuracy or the actual utility of your model for the task that you're trying to do. And doing this in a way that's like robust, no matter if you're starting from like, temperature 1.0 or 1.1 or whatever wacky sampler settings you have on like for VLM when you're actually doing the rollouts and actually training, ensuring that all roads like lead to this like correct place rather than potentially like diverging and going completely out of scope of what it is you're trying to make this thing better at. And I guess steps for designing and implement. Oh, sorry.
Yeah, go ahead.
Was there anything? Oh, yeah. Okay. Steps in designing and implementing a verifiable reward. I feel like the simplest way to think about this is like the thing that I recently pointed out to someone who wanted to get into this, who like was asking for my advice, or was asking for feedback. I'm like, okay, what's like a good toy task that I can like test this type of thing on? And I was specifically make a caps lock verifier, where it's basically just you take all the alphabetic characters that are like not numbers or symbols or whatever in your input text, and you just measure what percentage of them are capitalized, right? And just getting like a basic like maybe 100-step GRPO loop where you can see that yes, it's producing what it would have produced, but with capitalization. And another important thing is like doing that in a way where it's like you're not brain frying the model in the process. Like you're doing careful hyperparameters. You're using regularization, like clipping to its benefits to ensure that you're not myopically optimizing for whatever just leads to like more capitalization at the cost of coherence, but rather like how can I as seamlessly as possible make this reward number like 1.0 without changing the rest of the model's behavior? How can I do this in the most elegant fashion possible? And that's why I point out like the caps lock thing, because like it's easy to like measure, it's easy to look at, you just look at the completions to visualize like, oh, is it like is it trying to like capitalize in a way that is leading to like incoherence or repetition, things like that. I put a lot of emphasis on, maybe more than other people, in terms of like validating that whatever you're training on is like incentivizing the bare minimum required to actually improve the task. And in this case, it's not like a useful task. It's more like this is something that's like it demonstrates that it doesn't have to be like a concrete problem to solve end to end. It can just be whatever metric that you choose to measure. And I think that is something that is like broadly very powerful. And I think you don't want to get too pigeonholed on like RL is useful because it makes models better at reasoning, but rather RL is useful because you can assign arbitrary criteria, you can measure arbitrary things and get gradients from it based off of just the differences between different actions taken with policy gradients. That's the main thing that I think R1 and GRPO make people like I guess realize on an implicit level, but I don't see people like explicitly point out that what makes this so powerful is that it's versatile. Not necessarily that it makes models better at reasoning, but rather it exposes the right set of abstractions to make them actually reason. It gives you the actual toolkit necessary for the incentives to be correct at improving for those things that we care about for reasoning. If that makes sense.
That totally makes sense, yeah. And on the same lines as how verifiers and has evolved, actually, you talked about when Sikam said about synthesizers. So can you share
Mm-hmm.
your or what the progress on that and what you're actually looking up to it? Yeah.
So what Synthesizers is supposed to be is like what my end goal here is that this is going to be something that's like under the primary electoral. This is something like that is going to be like a project that other people on my team will use, and it's not just like my own thing. Is that between verifiers and between Primer-L, which now has like actual fine tuning support, so you can do like both like reinforcement learning or also just like standard fine tuning. The value add that I want to have here is like you have something for like the RL environments, you have something for training on those environments, but you don't really have something that's like set up for like building data sets, like or especially like synthetic data, where you want to have something that has similar design philosophy in terms of what Verifiers has from Will Brown and what Primer-L has from the organization, and that you want something that's modular, that's easily extensible without requiring like going into some long Python file where there's a bunch of hard-coded ELIS statements. We want to avoid that type of design more broadly. And there's no such thing that I can think of that exists for, this type of system that is like verifiers, but for building data sets and doing it in a modular way where you can sort of like stack hierarchically like transformations. Like, oh, I have this template, but maybe I want this template to wrap another template where it's like you have maybe like a system prompt where it's like sometimes you want it to be like a paraphrase version, or sometimes you want to like vary the amount of like query like responses that you get from the model with like different domains. Like there's just a lot that you can do in data lands that is like not very fun to like re-implement from scratch each time with like bespoke individual scripts that are designed for like data processing, which I think that's what a lot of people end up doing, converging to doing. They sort of like, okay, I just need like a hacky 500 line code script that just specifically works for my use case and does the specific set of templating that I need to make this work. But what I want is something that is more modular and extensible that I can reuse, so that I can see myself, maintaining with minimal friction that doesn't become that fits very cleanly into the ecosystem that we're kind of cultivating right now, with like verifiers existing for like environments and primarily existing for training in a general sense, in a way that supports like robustly asynchronous training where like you're like n steps behind off policy versus on policy. And I feel like the main gap between what we've built right now and what there needs to be is data work that is like done out in the open, where like I feel like you can sort of see this in what big labs are doing. Like if you use these models for long enough, you start to see, oh, so they're probably templating this in this particular way, because I noticed that something like Claude always likes to like hedge and add a little bit of like true but with caveats, like true but with nuances, things like that, even if it's like an obvious answer. And you can tell that this kind of comes from like a templating based system. It comes from doing this in a way where you can automate as much of the process as is possible while still getting robust results. And that is what I'm working on right now for Synthesizers, but it's not like super production ready. But I've definitely gotten a lot more progress on that recently. So yeah.
Pretty cool, and I hope you have a pretty good time with this. Next would be like you tweeted about this on I guess some weeks ago. So can you talk more about this Hugging Face for models which PI is building and you're working on, and what does it mean in practice to publish environments specifically? Are you talking about code, specs, APIs, or something closer to simulation snapshot?
So for the environment hub specifically, it's built around verifiers in mind directly, where the abstraction here is you have a single environment that like has its own code and has its own dependencies, and it takes care of like not necessarily like the data storage. Like maybe you have an environment that loads some data set from Hugging Face or whatever, or manipulates it according to some heuristic in order for it to like function as like an end-to-end reinforcement learning task. And that is what's being built for the Environments Hub, and we are like in the end stages right now of like finalizing this as something that everyone in the public can access and contribute to. Specifically, what publishing an environment means in this context is all the associated like abstraction that comes with end-to-end doing inference on the model, getting your scores, and like dispatching them for each of your rollouts for end-to-end reinforcement learning training. And on top of this, we're trying to figure out incentives in terms of what it takes to like build a healthy ecosystem and incentivize people to like build on top of this instead of just being like something that we use that other people don't really get like mileage out of because like there hasn't been like a push for it, or like it's kind of hard for there to be like an organic like growth for something like this because it's not something a lot of people are doing in general outright. And a lot of people that are trying to do it right now, they're like funding they're starting their own companies. We're like, oh, we're gonna be a company that does environments. We're going to like work with the labs to the frontier, and we're gonna do our own thing there. And I think there's a lot of people that are doing that like sort of in parallel at once right now, where like each of them are like independently siloed. And I think if you want to stand out in an environment where that's happening, you have to like address what other possible form factor makes sense for this, which is an environment hub where people can publish and meaningfully aggregate progress and like have transparency in terms of like, oh, I found this bug that was doing something really subtle in your reward function. We want to cultivate that kind of philosophy where we don't want to be like necessarily, oh, we're going to make a bunch of super amazing environments all by ourselves. We don't want to be like that. And truthfully, like, I don't think any one team is going to be like stand out in the sense that they can cover all the niches, they can cover all the domains. There's a lot of specialized domain knowledge that you're not going to be able to tackle as a generalist team. And I think something like this is also especially relevant for anyone who's just trying to productionize these models to do something special, where they don't want to have to build from scratch. They want to have something that's like robust and trustworthy. And there's the seeds for that being laid out right now, but it just takes, I guess, active iteration and continuing what we're doing to make that a reality. And the bounties for like, oh, we'll give you like compute credits or like potentially cash bounties. I'm not entirely certain what we've decided yet for that. Is we want people to be building on top of this in a way where it's like, it brings a lot of attention to us, obviously, as like a beneficial side effect, but also the people who are learning to use the stuff that we're building, they get something out of it. They get something tangible that they can use that looks good if they want to be at one of these companies, that is doing like that is coming from that angle, like, oh, we're going to do environments, we're going to work with the frontier labs, and we're going to do our own thing. Like, people can get their start working on environments that are like, built off of the environment hub, where like they have no idea how this works, and they get their footing, they start building intuitions, and some of them might eventually join us. Some of the people who are like tackling these bounties, there's a lot of positive like consequences where I think it's like mutualist benefit, and I think that's where a lot of the intuition comes from. Is like, if you want to cultivate a healthy ecosystem, the incentives has to be right for building that ecosystem.
Truly, and actually, when I first saw this, I got intuition of like it could be something like a GitHub or Hugging Face for RL. And when you get the environments done, I guess it gives pretty much intuition or a layer to everyone to actually try and test out and build the environments basically. So I guess, yeah, this is pretty much about it. Next would be about so people generally like try to know when you're deciding on what experiments to run, how do those ideas actually come to you? Is it more systematic, or like extending a line of reasoning, or more opportunistic, like noticing quirks and testing them?
I think it's like a mix of both, but like broadly, I would say it leans towards opportunistic exploration. I think the important thing is that as time goes on, and I do more of these experiments that are just like immediate curiosity. What if I did this? What if I did that? The things that like manifest as like put guns inform like even like on an implicit level, where is the right place to go next, rather than just like, I'm going to keep on doing something that is like never going to scale or whatever, even after the first time that it didn't work. Like, I think as long as you meaningfully absorb like intuitions like from the actual experimental evidence that you have for like any piece of research you're doing, any experiment that you're doing, you're going to be able to narrow that search space down to something where it's like actually useful. But I think there is still value in like systematic exploration, where you're trying to cover like all the bases of a certain problem space. It's just that depending on the scope of like what you're trying to do, like how fast you're trying to do it, you might have to eschew some of that, and you might have to, I guess, build robust heuristics for what does and what doesn't work. And a lot of it is implicit, and a lot of it is I feel like a lot of it develops as like more than that, though. Like, I think there's certain things that I'm like, no, we should never do that I would not have said that about like 12 months ago, that I feel so strongly about now, because I've been guided sort of by the broadly opportunistic curiosity driven research that I've been doing. And it helps to concentrate on, like, I guess if you're someone like me where you do a lot of general experiments and you try to really like cover your bases in terms of understanding how the stuff works. You want to form general intuitions about what works for the system versus what doesn't work. Uh, one main thing that I think separates my thinking now from what I was thinking whenever I started out is like how much more global I try to think of what suggestions I have. Like, am I adding some like dumb extra term or a second order like optimizer trick just because it's intellectually curious to me? Like, in end to end, what value does this provide to the system? Like, at the end of the day, what do you get from this idea if it's executed? That's something that I ask myself way more now than I asked like a year ago when I was just like screwing around and picking around and getting like some direction from nothing basically. And I think there's still value, of course, in like systematic research. It's just like you have to be able to uh, have meaningful principles and intuitions that are based off experience that are like reflective of the things that you're working on, the types of systems that you're working on, in order for that to be like meaningful. Because otherwise, the search space is just too large of all the things that you could explore. Like, there's so much that I could be doing that I'm not doing that I want to do at some point that is just not high leverage right now. That is just not the right, like, it's not the right time for me to be working on some of the things that I want to do. But I'm confident that like I get to a place where once we have more of the fundamentals secured, once we're better at like the basic bread and butter of like, you know, what it takes to build these systems, which is like good infrastructure, good data, obviously, especially people discount that all the time. They hear it, it goes in one ear and out the other. They don't internalize it. It's hard to internalize until it screws you. And then you realize that you cannot take that for granted. You cannot take the data being screwed up in some subtle way that's gonna like, you know, screw you later. And it's like it's the worst type of tech debt because like it's not something that you can like express through logical language. It requires a lot of just staring at it and understanding on an intuitive level where this is wrong and how this is wrong and what it would take to fix that as minimally as possible. But yeah.
Oh, interesting. Like also, if you have to define in 2 lines, what does taste in research mean to you, and basically what ideas basically to explore about and whatnot. How do you define that?
I would say what I define as tasteful is stuff that, you know, still generally applies to types of heuristics that I've been describing, where it's like understanding that there's a very narrow subset of all possible ideas that is the best that you should be working on at any given time if you want to like, you know, make a big impact. Like, you don't necessarily have to be like super impactful. You can work on that thing that nobody else is working on if your heart so wishes to, but that's not the type of research that I want to do. But I think another thing that governs like, you know, what is tasteful research versus what isn't is stuff that um, attempts to maximize like maximally achieve the combination of like a novelty and like utility instead of just one or the other. There's a lot of really interesting novel work that goes on in research, and there's a lot of really interesting practical stuff that does not really happen in research as much as, you know, the more theoretical elements in terms of like the attention, at least. Like, there's still papers that like explore really interesting things that are practical that don't get as much attention. One of them like that immediately comes to mind is like Fourier embeddings paper, where it's like, oh, this is like tackling like an actual specific problem that nobody else is really addressing right now, and it's in a way where it's like, you know, it's both practical, it's both like a novel. It's not like a novel in the sense like, oh, this is like the millionth paper on long context extension. It's like, how do we make these things actually good at extrapolating to longer sequence lengths without being trained on explicitly? What are the actual bottlenecks for the transformer to actually just learn this from like, you know, a sequence of 512 positions and be able to continually predict correctly up to like 2,000 or 4,000? And what it takes to be tasteful is trying to maximize that utility and novelty jointly rather than one or the other. And there's not a lot of research I can do that because it's really hard to like make really interesting developments that are not like sort of like ham-fisted or like we combine something with some other thing that already exists and nobody's done that before, so we're going to call that a novel. You don't really see that in the types of works that I'm thinking of that manage to balance that utility to novelty ratio, where they get some like theoretical insight that is actually actionable. And the problem is like most theoretical insights are not actionable. They teach you something about the system. They teach you something about how you should approach developing ideas to improve the system, but they might not be necessarily useful on their own right. And I think that is what like governs tasteful research versus like stuff that are like, meh, this is not going on the reading list, you know?
Yeah. On the similar line, when it comes to supervised fine tuning, it is often thought of mainly as instruction tuning. But as RLHF and RLVR start to deliver better outcomes, how do you see the SFT phase evolving in the future? Do you think it will shrink in importance or find new roles alongside RL.
I think in the past, a lot of people tried to like cheese as much performance as is possible, just for like training on the domain as hard as possible. But I think that conflates the utility of like what this actually teaches the model versus what you actually want in terms of like separation of concerns, where reinforcement learning enables you to get like specific concrete metrics out of like the thing that you've fine-tuned, like that are not necessarily like guaranteed by fine-tuning, like code that always compiles or code that always like follows some specific rule that you want it to be followed. You can in aggregate broadly steer the model in the direction of predicting outputs that are like that, that are like or at least usually like that, but you shouldn't try to overfit so dramatically on the data itself in order to get improvement on those metrics. And what I see it as being useful for, especially, is like if you have tasks that that your original model just does not have expressive enough modes to like be able to reinforce over to get the outcomes that you're trying to do. Like you can't teach a model to be more respecting of ambiguity and like nuances in terms of like I'm not sure if I know this information, blah blah blah, if it's not already predisposed to some extent to doing that some of the time. And I think like a clear example of what I mean by that is like you see these models where it's like they fine tune on a lot of synthetic like GPT data where like no RL is directly involved, where it's like you sort of lose the original generalization capabilities of the model in order to get improvement on those metrics, because you're doing it in the most like I guess like brute force way. You're just trying to train out a bunch of synthetic data by itself with no understanding of like what are the things I actually want from this data point. You want the general shape down. You want the general format. Like if you're trying to do instruction tuning, you want like the basic expectation of like there's like an assistant role and there's a user role and maybe there's a back and forth. But once you have that shape down, and once you like you shouldn't need that much is what I'm getting at. You shouldn't need more than like 200 million for like a lot of things really in terms of like total trainable tokens. But I think it is not necessarily true in all cases that you even need SFT for RL to start working, but that doesn't mean that it's not a useful prior. That doesn't mean that like it's something that you shouldn't do or like you shouldn't get most of your gains from. It's that well, that's a bad way to put it. I was thinking more like you're trying to minimally steer the model in this direction to be good at the task during the RL phase. And the SFT phase teaches the like basic form factor of like what RL is going to like hill climb over. Like if you train on like R1 traces, there's going to be an expectation of a scratch pad, and that's always going to like come before the answer. But if you have something that's like a standard language model that has some degree of instruction fine tuning, and you're just trying to make it more robust for things like multi-turn consistency, you don't necessarily even need an SFT prior for that, because what you need is good at concrete metrics for the thing that you're targeting. Sometimes you need to train on data to get it to start exhibiting things that you're trying to reinforce, and sometimes those things are just properties of some of the possible distribution of outputs that you want to select for and specifically condition the network to improving. And a lot of that can be very precise. You should probably be a lot more precise whenever doing post-training these models than what a lot of organizations will do, where they just like, they sort of don't even think about like the trade-off between like how much you have to change the model to improve performance versus like how much that impacts downstream performance on unrelated things. And there's some cases where maybe you don't even need to think about performance on unrelated things if you're not trying to build, generalists. And that is true to a certain extent. But it's also like the nature of learning. Do you really want updates that are like catastrophic, that are kind of like, that are so like heavy leaning in one direction where the model becomes like worse in some other thing that you're not even like training on? Like that to me is a sign that you're like training for the wrong things, or you're like optimizing for the wrong behaviors in some sense. And I think there is a lot of value in rethinking like SFT in terms of like what you're trying to get out of it. Like if you're trying to train a model to do something like very particular, it may be useful to have some baseline SFT that is like for generalist instruction following, and then you specifically Anthropic does a lot of this. They do context distillation as opposed to like raw SFT. Like I wouldn't be surprised if they don't do SFT in like the standard sense at all, and instead use like in-context learning from like few shot examples and context distill do like the first turn and the second turn and like and so on, where they use the models or like existing capacity to like follow in-context examples and specifically distill that representation of the thing that they want as like a default mode that the model falls into. And I think there's a lot of fine-grained behavioral steering and fine-grained reinforcing that you can do as a property of that I think people take for granted, because like it does make sense, like especially if you're like an organization that isn't specialized in this technology and you're just trying to find a way to productionize it then what you need is something that's good on your immediate metrics. But in terms of like the philosophy of designing these things and making them more robust, I think more thought and care should be put into making them like as anti-fragile as possible is how I would put it. As like robust and resilient. Like what happens in for example, like, oh, we train like a vision model to transcribe like text from images. Well, what happens if I take that image and I just put random black boxes everywhere? How should the model behave in that situation? You need to think about the edge cases. You need to think about what the default assumptions that your network is falling back on for the task at hand. And I think the more comprehensively you understand what that looks like and what it is that you need to change to make something work, I think the more we will understand how to build performance systems that do not break at the edges and are not, that don't lie on the jagged frontier where like they're very selectively good at a handful of things, but completely catastrophically fail outside of that. That's not something that is going to be very useful in the future. I think there's going to continue to be direction in improving generalists, not even necessarily as like as the end goal itself, but as like a means to more efficient specialized fine tuning, where it's like, oh, in order to build something that's like the most general fine tune, we want it to be maybe context distilled, where like it has examples of what the right answer actually looks like for this problem, so that rather than training on one example of the correct answer, we train on a bunch of paraphrased examples of that same answer that the LLM already saw in context, and we just context distill it as if it already knew it. Things like that, where you can. There's definitely more juice to be squeezed in terms of not brute forcing it, I guess is broadly the point that I'm trying to make. But yes, I do think that SFT is like not as important as a lot of people want it to be. But I still like I give it roughly the same level of value in terms of like what it gives you from the beginning, in terms of like a baseline that works for actually getting rewards on your reinforcement learning.
Interesting, and I guess the recent progress in RL, the reinforcement retraining, I'm not sure how people have different opinions on that. But yeah, like the people who have been scaling RL on the terms is actually like people thinking more on those lines, not much beyond SFT. Next question in the list is okay, why can't we just train a really good regional model with little knowledge? And what are your thoughts on GPT-OSS and the push towards hierarchical reasoning models? Do you see them as a promising direction or more of a distraction from where the real progress will come?
I think broadly, it's like it's a trap of what's immediately useful and what people want to be immediately useful from these systems. Like, I think the idea of like a platonic ideal reasoner that's like, oh, it doesn't have much knowledge, but it can just look it up. It can just like tool call. It can just do like, I think it's besides the point in some crucial ways where it's like you need to have like a good for like baseline assumptions about how something works to make logical deductions about it. And if we try to build these things around the assumption like, oh, it doesn't actually need to know anything about the world, it just needs to relearn it from scratch every single time it's used, question mark. It's like I don't see the appeal as much as some other people think. I think a part of it is like people have like a notion of like, oh, small models can't have knowledge, therefore we should train on less knowledge and more reasoning, which is, I think that's like the only reason why these systems are so powerful in general to begin with is because they've absorbed the corpus of web text over like humans communicating naturally and candidly about all sorts of things and learned compartmentalized representations of those things. And those representations are like very powerful and general purpose up to a point. And it's not like that falls apart at like, the 7B model or like the 14B model scale. It's just lower fidelity. You should still try to make a model that, knows at least the basics about general world knowledge and information, even for the things that you think aren't immediately useful, like, oh, it doesn't need to know about pop culture. No, it should know as much about the world and what the people that live in it as much as possible if you want it to have a good world model. Else you're going to have a skewed model that's biased by what academics might think is useful to know. And like, you can't over-index on STEM, you can't over-index on mathematics, you can't even over-index on programming, I'd argue, but programming probably has like the most utility in terms of generalizing to other things that I would put it like, this is not as bad as like trying to pre-train like on like a 100 trillion mathematical synthetic documents in latex format or whatever. But the core intuition here is like you don't want to bias the space of possible actions with like data that's supposed to be like, oh, this is good reasoning data. You should try to get that mode as naturally as is possible from even the smaller form factor models. A lot of that comes from more careful optimization, not by excluding a big chunk of the distribution arbitrarily based off of heuristics that might be intuitive to the people who vouch for this approach, but are like ultimately doomed. They're ultimately going to be subsumed to like by scale. They're ultimately going to be subsumed by people learning how to build smaller models that actually are better per parameter in terms of representation, which is, that's not going to be done by filtering for like, phi, or how do you pronounce it? Like phi from Microsoft, phi, where like you're training on like the most synthetic textbook looking distribution possible. But
Yeah.
now it catastrophically fails whenever the user has typos because it was never trained on typos. That's the type of thing that I'm worried about. In the limit, obviously, that becomes much worse of a problem. What GPT-OSS does is kind of like, the it drives the concept of we can just train for reasoning from scratch to like
Mm-hmm.
it 10x's that concept, and I think it starts to really show, and that's why there's a lot of really mixed reception about its actual practical utility, because they didn't train it to be a generalist first; they trained it to be a quote unquote reasoner first, and that is making a lot of assumptions about what is useful in the distribution that you're learning from, and I think we should make as little assumptions about that as possible.
Okay, that's really interesting. People more talking about GPT, OSS, and HRM. Probably we can move to the next question here.
Yeah.
How do you view the recent open source surge in Chinese AI research, or basically open source AI research, specifically models like Kimi-K2, Quen, including Quen 3 Coder, GLM 4.5 from ZAI, and others? Yeah.
I would say the main thing that sticks out to me about Chinese open releases that have happened is that they're taking this technology, I think, much more seriously on like a fundamental infrastructure level. There's much less like screwing off to like chase your own moat type effect that happens in startup land for especially in America. But like this obviously didn't come from nowhere. This came from like the fact that like it strategically makes sense in terms of building fundamental capabilities. Like you get a lot of things for free whenever you release models like out in the open, like in terms of like people building infrastructure, in terms of like, I think VLM is an example of like, before DeepSeek V3, it wasn't really a universal expectation that your SGLang or whatever it is. When it comes to the approach and impact, it definitely makes sense strategically, especially is like, I think China in general is taking the technology and its advancement much more seriously. And this type of release is not just immediately beneficial for like goodwill reasons, but for like infrastructure reasons. People can build around these models as they're released. They can, have ubiquitous support for like fine-grained mixture of experts in the style that DeepSeek basically pioneered in a sense, in terms of like, scaling to, much larger splits of experts, much more FFN dimension splits. And that's the type of thing that that sort of builds robustness in terms of like general infrastructure. There's not like one provider or like one company that has like, I guess, a monopoly on any of these individual variables that are like important in terms of like how these models can be made useful. And you don't see nearly as much of that in America, but it's something that Preman like definitely wants to do more work in terms of like, pre-training in the future as well. But right now it makes the most sense for us to focus on what we've been focusing on in terms of like reinforcement learning and doing the, the fundamentals really well when it comes to post-training and building powerful general purpose models, especially for multi-turn and tool use scenarios. But yeah.
Interesting. And my next question would be, if you had to define it, what is the art of training a good RL model? What do you think separates a well-trained RL system from just another model that happens to run? Yeah. And how to be a better experimentalist on those regard? Yeah.
I think something that will come back to bite you is like you can't really think of all the possible ways that like an environment might incentivize the wrong things ahead of time. If you're getting into this like just now and you're trying to build intuition for this type of problem, something that makes sense to do is like once you have a first iteration, carefully document and maybe even like taxonomize the types of failures that you still see exhibited in the outputs, like qualitatively. Where does this fail? Where does this work? Is there some edge case in the data or some edge case in like how I'm doing the actual verification itself, like on a programmatic level? You shouldn't try to like, I guess, perfect it like immediately on the first try. And you should also go in with the expectation that there's going to be some like, oh, I accidentally did something that's leading to reward hacking. Maybe I set up the incentives of like my reward shaping in such a way where it's like I'm accidentally like preferring something like like the simple example is like you train the model based off of like percentage of tests passing, right, or something like that, and the model ends up removing all tests but the ones that are like easiest or something like that, and so the percentage reward is higher. Things like that where you might not necessarily like see how these things fail on the first try, but if you're building them from scratch, what you should generally be doing is getting a like representative sample of like how an existing model before even training on it. Like it could be an API model, for example. I think what Will likes to do whenever he's demoing environments is he'll demo it on like a I think GPT like 4.1 nano or mini, like the bigger of those two, whichever it was, and he'll get like a subset where like he'll filter by like the highest rewards or the lowest rewards, and it becomes that much more easier to like debug and understand like where something is failing and where something is succeeding, or if it's like measuring the things that you care about reinforcing rather than there's something that there's a dumb way that this can be like a high reward that isn't actually reflective of what I'm trying to incentivize. So it's really a lot about incentives, and you can't fully understand what the
Pretty
path
cool.
of least resistance looks like.
Yeah. Also, I'm curious about when you dive into a new area, what's your usual process for building knowledge? Do you start with papers, code, people, or something else entirely?
Whenever I'm trying to do something like just like kind of out of scope for the things that like I'm familiar with or like requires like domain expertise, uh, I try to focus on the core thing that like sets apart how people in the field think about this thing. Like not necessarily like the jargon by itself, but like the relevance of that jargon in the context of where it appears. Like I think a lot of domains, there's some domains that like have like conceptual overlap in terms of how they think about things and how they approach things, and there's some domains where there's like no overlap. They think differently, and if you want to understand a domain, you don't want to just approach it from like, oh, I'm going to learn according to how people say things work in this domain. You want to think about how people in this domain usually think in terms of like the theory of mind element, where like what would like like if I was like in signal processing or something like that, like what intuition would I have, like what is the utility of Fourier transform, why am I using this instead of something else, like, and what role does that play in terms of like what I'm trying to do. Like if you're trying to like denoise something or like work with like spectrograms, like there's all sorts of domains where like people think differently because there's kind of different rules for different subsets of knowledge, and so those rules are sometimes like they're sometimes based on good intuitions, and sometimes they're based like sort of like on dogmatic, I guess, like this is how things have always been done, so we're going to do them this way type thing. And it's important to like weed out what like the textbooks say versus what's actually useful, and most of the time you can do that pretty reliably just by thinking about like what someone in this field would have something like some unfamiliar concept that you're trying to understand like the purpose of and the intuition of, like why are they using this instead of something else, what role does this play that you can't like get from something else that like is unique to it, and sort of disambiguating like why things are used rather than just learning about them independent of the context of where they originate, and independent of the context of like the people who popularized or like canonized the types of methods or heuristics or I guess parts of knowledge that come with domain expertise.
That's quite interesting and pretty much practical as well. Also, when you are in discussions with people who have more formal training, like people who have PhDs or years of research experience, how do you handle disagreements, and how do you get them to take your more hacker first perspective seriously?
I think that whenever like it comes down to it, if I want to provide like theoretical or like principled observations about like why you should or shouldn't do something, or I can make pretty compelling arguments, like as long as like I think like diplomatic about it, like something that like I do kind of unintentionally, and I think like it just kind of surfaces whenever you get any kind of traction on like a social media platform for like a long enough time, but you end up like sounding meaner or harsher than you like tend to like you intend to be. Like it doesn't come from like these researchers are dumb, what they're doing is stupid. It's more like you take like offense on some level from like an intellectual perspective of like what something is doing and like how it could be like done better. And I try to balance like the types of remarks and observations that I have that like might not be obvious, like in and try to build up a profile of like why though that's obvious to me, because and that can be hard sometimes, because like a lot of what I put out there, a lot of what I publish is sort of like there's this implicit knowledge that you have from following me for long enough where you can see why I think the things I think, but from like the outside looking in, sometimes it just looks like I guess arrogance, or like I guess faith and commitment in opinions that I haven't like correctly justified. And in those cases, I try to do my best at like laying out, here's the experience that I had that in my eyes, in my own experience, justifies why I think that you should or shouldn't do this, and here's why I think this is relevant to like your work. And that is something that I feel like I'm getting better at as time goes on. And some of it, like I do feel like a lot of it is like just unintentional. I sound meaner than I ought to in terms of like getting across an idea. Like it's like counterintuitive, right? In terms of what you actually want people to gain from those types of conversations. You don't want to just argue pointlessly. You want to make it clear why you believe the things that you do, and I think that's the type of rigor that I try to stick to.
That totally makes sense. Also, a lot of these big labs, when it comes to OpenAI, Anthropic, and other, are pouring billions into RLHF pipelines. Do you think they have already logged in the standard recipe, or is the recipe still very much up for grabs, or something novel coming up to it? Yeah.
Well, RLHF, like just like the basic form of it, no external rewards. There's a lot of tricky implementation details. Like you have your like at the core of it, there's like the bare Bradley Terry loss where you have like a scalar, you have an output head that's just like one dimensional and go from negative infinity to infinity, and you have a sigmoid where it's just like you're taking the pair and you're trying to maximize the difference between that pair for the given examples you have. And there's many ways that you can do this. Maybe you want to normalize it according to like some particular scale, or like perhaps you want to optimize it in such a way where you're not just taking like a single token scalar like at the end of the sequence, but maybe you want to train like encoder decoder with like the causal mask turned off, and then you take the mean of all tokens and like the response that you're actually trying to judge like in the like RLHF setup with pairwise preference. And I think there's a lot of variation here, like more than people realize in terms of like the implementation details, in terms of like what the learned reward model will actually pick up on. And I think there's wiggle room to experiment and do things that are like slightly novel in this, but like I don't think a lot of it is like fundamentally like boundary like breaking. It's more like there's a lot of small things that will come to screw you if you don't do them right and you don't ablate them thoroughly and you don't like meticulously detail what the differences are between these methods. And I think a lot of that just sort of it adds up to a product that is like it's greater than the sum of its parts as a whole. What you get end to end whenever you get all those little details right. And I think there's a lot of value in chasing novelty where it'll benefit you in a way that's like very generally applicable. But if it's like one small implementation detail level trick, I don't think that's the stuff that like necessarily moves the needle. But like in aggregate, all those little tricks add up to like a stack that other people cannot reproduce and not create. That secures like a moat, because it's good engineering, it's good taste and research in terms of like what makes sense to prioritize. I think another thing about RLHF that I think is interesting, it's not really explicitly pointed out, is like we were already doing reinforcement learning on language models for like the past few years. It's just we pigeonholed it super aggressively to learn heuristics deriving from a model on pairwise data of human preference, which is a very, very specific thing for the industry to kind of like concentrate so heavily on for such a long time. And the rebound that we're seeing now is like, okay, this can be much broader in scope. You can target much more than just this specific setup for something that's like barely like done out in the open outside of the big labs, competently at least. I mean, NVIDIA has done some like interesting work there, but like whenever you're actually at a frontier lab doing this for like a living, you start to really care about the real little details that will give you this edge, because nobody else cares about those details to the extent that other people might be taken for granted. So I think Anthropic is the one that comes to mind immediately as like they understood the limits of behavioral cloning sort of from the beginning, and what you need to do on top of that to get the actual qualitative behaviors that they're looking for, especially for agents, but also for like the general design philosophy. It's like it's downstream of, I think, the kind of like less wrong effective altruist like culture that Anthropic seems most closely aligned to, where it's giving them an edge in some ways, I think, in terms of like design philosophy, but also it makes them kind of like aggressive and weird and esoteric in other ways, where it's like you see someone like Dario Amodai, where he's like aggressively pushing for sanctions. Like this is exactly what someone in his position like it makes sense that he's doing this, but it's like at the same time it's just kind of like you hate to see some of that, where it's like I guess fear becomes a predominant narrative. It becomes like the default outcome in some people's minds, and it's never really hit me on like an intuitive level. I understand how things could go wrong, and I'm especially not like naive to like the real world dangers that these things can present to people as of right now. But we mustn't let abstract theoretical risks become that much of a driving force in terms of like how we build these things, in terms of like letting fear concentrate it. Like I think we should keep it in mind as an intellectual curiosity, but not as something that is like guaranteed to happen, because like the more you try to like wish that into being the default outcome, the more like people are going to like, how do I put this? It's like there's a good term for this, where it's like the more you focus on like trying to suppress something, the more it becomes prominent. It's like You don't want to like develop a world where AIs learn from literature that has like a default stance of everything is going to go wrong because it's going to become super intelligent. And there's going to be like existential risk that's going to like threaten humanity. Like that, like if you want to be in that timeline, you would be worrying about it. That's the point I'm trying to make. But yeah, a little besides the
That's
point. But yeah.
that's quite insightful. Do you think we are underestimating how much progress could come from designing better reward signals as opposed to just scaling up bigger models? Also, on terms of alignment, which is more about getting better at preference modeling or about escaping preference modeling altogether. Yeah.
So as for the question of like which is more valuable, bigger models that are like just more fundamentally complex can represent more versus better objectives, ensuring that what we're optimizing for is actually in direct alignment with the things that we care about. I still lean very heavy towards the latter. I mean, there's still a lot that you just get for free through scaling and through bigger models, but if you hit a wall of specification, then you can't get better than what you can't measure, essentially. And I think that's going to be the bigger bottleneck, especially as there's continued investment in things like data center build outs and in general, the problem of what you're actually trying to teach the thing to do is going to be a bigger one than the like engineering challenge of like how do you make it bigger, how do you scale it. There's less immediate engineering solutions here. You have to think more, I guess, from first principles about what you want the system to do or what you want it to be capable of, and what properties of that system make it actually useful. Uh, in terms of like fundamental capabilities, like what you see with something like agent training with like Sonnet 3.5 and that finally working, it's not really like a unique miracle of like the pre-training. I mean, if I had to guess, they had the stack for like the new Sonnet on the old Claude 3 Opus at some point internally, and they were like, this isn't different enough that we can like ship it as like a full model because we've already gotten so good at specifying what we're trying to solve here that what we're optimizing for is like only the tail end really benefits of like the extremely difficult stuff in terms of like those bigger models, and so that it's harder to like have an immediate economic justification for models of like Opus's size, and I'm assuming they're the same size for each iteration of like Sonnet and Opus. So I see that in Claude 4 Opus. I see it like not really being that much better for like general comprehension and general ability, but for the tail end where there is a difference, you see a dramatic difference, but only for that tail. And so the question remains is how much of this tail is actually economically important to actually be good at versus how much is important to be good at for like capabilities reasons. Like we need to be on top, we need to continually progress so that we're not behind and that we have something that they don't have. I think that's the kind of internal thinking that motivates what a lot of big labs are doing and why big models are here to stay, even if the mid-range model that's well trained could probably do as well as it even in the general case. It's because if you want to continually progress, you can't just settle for less, essentially.
Pretty interesting. Also, I guess we have pretty much talked about RL and reasoning. I'm just curious, 10 years down the line, what would success look for you, both personally and in terms of kind of work you want to see out in the world coming ahead?
I think in terms of 10 years, what I want to see accomplished is significantly better ecosystem that is, I guess, self-dependent, in the sense that like if I decided to like retire or something like that at that point in time, my most important contributions like have been made already. That's like the ideal, and the types of contributions that I want to make are on that ecosystem level of where you build something that is like enough of a like independent feedback loop that other people can build upon it and like extend it even like long after I like if I hypothetically retired. That's the type of long-term impact I want to have. Like concretely, I also want to get really good at the fundamentals of the types of things that I think are important, things that maybe people don't factor as much whenever they're thinking about what they want out of these things that they don't even know they want. That's the type of thing that I want to like aggressively explore in terms of avenues. I want to get pretty good at the general stack in terms of working with data and continuing to work with it. But I also want to, I guess, go for the juggler in terms of like novelty and like really find these avenues that other people are just not that interested in exploring, or there's like economic concerns in terms of like this is not the useful thing to be working on right now. We need to work on the thing that's proven to work. And I think agents right now. That's like the hot new thing, but that's like in my mind, it's kind of a side quest. We've gotten much better at specification and making these things follow orderly rules in a feedback loop that is like productive and sustainable for like development of capabilities. But I think there will be more unexplored avenues to like travel down that we haven't yet. That we kind of need to like unlock the other things first before we can get there. Like I think a lot of progress is like inherently sequential, and I think that's a part of why like I think that it could take like a decade or longer for like what people think of when they think of like AGI.
Yeah, totally. And I guess we are pretty much in the middle of the agent wave right now. My question to you is, from your perspective, do you see actually agents being really promising, or something more to be done ahead? And if they're promising, what you see next coming up in the agent space right now, as they say, 2025 is being the era of agents. Yeah, how do you look up to the space?
Well, I think the main bottleneck is permanence of state, permanence of building on what came before. Like context windows are a useful abstraction if you need to serve these things as like static checkpoints that can adapt in context. But ultimately, if you want longer form work to be done autonomously by these things, you need to capture permanent representations of state. And I think there's a lot of promising research in this direction that I would like to build on myself that I don't think right now is the right time for me to be working on. But it's the type of thing that I think you would intuitively expect these labs to start pivoting towards now that the basic feedback loop has been established. But I think we're going to see, like my basic prediction here is we're going to see a lot more investment in the current direction and polishing it and making it work better for other domains before we start seeing things uh, like overnight LoRa training or something like the cartridges paper, where it has been specifically designed for this type of representation of state, where you can capture it based off of like in context examples.
Yeah, and yeah, I do sense that there's a lot to be done on the side, and but yeah, we are progressing pretty much. Uh, Next would be like the phrase post AGI gets thrown around a lot, but looking at how models are actually evolving right now, what do you think is fundamentally broken about the way we are framing progress? And if you could plant one question in people's mind about the future of intelligence, what would it be?
I think at some point down the line, like in the long term, probably not in the immediate near term future, we're gonna have to like make more fundamental like we're gonna need to be more comfortable asking questions about what it means to have these things exist for purely instrumental reasons, like as tools versus as some autonomous entity or thing that uh or like in the limit like something that has like the same legal status as like personhood, where like if these capabilities like continue as they have been and we want these things to be, I guess, self-governed rather than human in the loop, then at some point there has to be like a disconnect between like what we are specifically like designing them to do versus what they can do given like just the sparse feedback. Like if you teach like an employee at like a job or something, like if you're a manager and you're in charge of someone else, you give them feedback directly and they learn something from it, and something internally happens where there's like a shift. There's real continual learning happening. It's online, and that feedback is sparse. That feedback is not something that you directly measure through a signal that you can do backpropagation over with a bunch of rollouts in parallel on VLM. It's like that type of feedback is something that is really hard to execute on, because now the measurement is not something that is like squarely in the zone of things that you're trying to make it better at. You're creating something that is like just purely an emergent consequence of like optimization pressure given like free reign to decide its own direction. Eventually, we're going to have to pivot to that form factor if we want true generality and versatility, because it will have to be, if we want these things to be completely autonomous, they'll have to know what's good for them by themselves, in the same way that human individuals can, for the most part, be trusted to know what's good for themselves. And I think we're a long ways from that, but we're going to have to stop thinking about things in terms of evaluations. We're going to start having to think about the fundamental principle of how general the thing that it can learn from scratch is with minimal supervision. And that has a lot of questions that are not easy to answer in the current, I guess, in the current status quo of how we serve these things and build these things and make them useful. Like there's fundamental tensions between the business models that exist right now and something like that, in terms of like the form factor that would need to be, the form factor that it would have to come in.
True that, and I guess the post-AGI world is pretty much subjective. It depends on the people talking about it and their own expectations. Um, Next would be it's one of the question I received. What's the weirdest or most unexpected part of working at PI, which you find interesting? Yeah.
How absolutely massive the office is. Like, I remember just got like last night. I think Chasm. You mentioned like yeah, well, the primary like I was like I knew that everyone said it was big. I didn't know it would be huge. And it's like yeah, I mean they want to fit as many people in there as they can that can work in the office. And it's like right now actually we're in a different place than we were before, and it's like pretty nice. There's like a working area where everyone's like concentrated in like uh big spacious living room area. Pretty tight. Cool.
It's fun, I guess. The next part in the pod is trivia. So this will be some of the side questions or some of the fun questions I have got or curated. Can talk more about it, I guess, in a minute. Yeah, I guess you will enjoy this too. So the next is so do you ever get code reviews from Will, and how much time do you usually end up spending with him in office? Yeah.
I honestly, most of what I've been working on has been on like the trainer side, and what will still focus like full time on like Verifiers itself, which he does do things for Primarel, but like it's not his like forte in terms of like knowing where everything is and knowing how these repositories are getting like a lot of active upkeep, so things change pretty rapidly. I would say most of the time I have Demi or Mika do pull request review because Will is usually like I'm usually making code changes to things that are not like directly offered by him or like not really his domain of expertise to say.
Wow. And how's your day-to-day dynamics with Will or other researchers at Pyramid Labs? Yeah.
Uh, I mean, what I have is like a hybrid remote work position, so like the dynamic is definitely different, like between like in office versus out of office. But I do try to keep up with people regardless. But like sometimes, like I would say Will's just in general like a pretty busy guy, so it takes him time sometimes to just get back to like stuff that I would like to discuss with him. So usually whenever I am when we're scheming or brainstorming something, like it's usually whenever I'm in office and I'm thinking more about like if I want to move out to like SF full time. Uh, it would definitely there's a lot involved to that though, so I don't know about committing immediately, but I think I would definitely be spending a lot more time like speaking one on one with him and co-developing compared to now, where it's mostly like meetings where we'll catch up each other on what we've been working on.
Pretty cool. Um, how much will spend reading research papers in a day or week? Yeah.
Not that much, honestly. I mean, usually what we've been doing for a good period of time is we'll have like paper reviews where we'll specifically sit in a call like as a group and check out something that might be relevant that we can pull insights from or implement in some fashion. And he's there for that whenever we do those. But I would say he's a very focused person, as I would like to say, like a lot on the specific things that he wants to build and continue working on. Like right now, he's like preoccupied with like the environment hub and like sending out invites to a bunch of people. And Twitter DMs is probably like one of the worst ways to do it, but that's a form factor that it happened to be most manageable considering his influence on the platform. So yeah,
Sounds exciting. Um, what's Will take in the lab? How would you describe his character?
I would
What?
say
Yeah.
he has a very unique, I would say, like predisposition towards like if someone has like a vague idea or concept or something that they need to flesh out, he's very good at, I guess, helping you think through that to its logical end and what you would need for that and like what the like on paper specifications, what you need to have to do what you want to do for executing on that. I would say he's better at me on that in terms of like getting like useful insights from things that are not like fully developed. Like I think he has a talent for that in a way.
Wow. Interesting. One hidden secret about Will, which TPOT don't know yet. If you have something in mind.
I remember at our offsite, our last offsite that we did, that ended in the Germany event that we had in Berlin. Uh, there at one point, like we were on a yacht, and a lot of the people were like swimming for a bit, and I can't remember who on the team said it, but it was like, "Yo, why does Will swim so majestically?" And then I look and like he's right. The dude's a majestic swimmer. Like, if he wasn't doing machine learning, maybe he'd be doing this. Yeah.
Interesting, interesting. Someone might quote it, I guess, on Twitter. Next would be, what's one underrated habit or mindset that has been yours age in research so far? Yeah.
I guess being willing to like trace back the why of what people say, like instead of just like taking like a figurehead, like like someone like Yan LeClune at like face value when he talks about JEPA, this is not like a surface, like I'm not like criticizing JEPA specifically. Like I have my own grievances, but like that's unrelated to the point that I'm trying to make here. I try to think about why, what happened along the way that led him to this direction, right? Like what's the history here, and you can learn so much about like I guess you can sort of like model other people's intuitions in some ways like better than they do in terms of like being aware of it. Like I would say like for Yan specifically, he has always had like this fundamental focus on like convnets, convolutional networks, and especially anything vision and spatial. Though of course it makes sense that he would build architectures that like use spatial heuristics that operate within the space of like vision, because he thinks this is like a fundamental property of like it's intuitive to him. And you can apply this to any researcher. You can apply this to anyone who does research that you're interested in. And you can read what other publications they're on, and you can look at things that were not published in the last month that are maybe overlooked. And there's a lot of value that you get from that when you just don't look at whatever like is the big meme paper that everyone's like pushing on Twitter, right? Like I want to call it a meme paper outright, because there's like the HRM paper, the hierarchical reasoner, where it's like 90% of the gains comes from like what the sparse mixture of experts universal transformer paper did, but like months ago, except that one didn't get as much attention for some reason. And it's like really all about branding. It's really all about marketing in some ways. And like, it's very beneficial to just explore independently of what the zeitgeist says at any given point.
Quite interesting. How do you see AI tech Twitter or the TPOT basically? What's the general overview when you log into the app and scroll it? Yeah.
I think there's accounts that don't really want to engage with the fundamental questions of the technology, but like kind of persist anyways to like engagement bait, which is like I guess yeah, that's like a surface level like criticism that I think you would get from a lot of people. I don't know if I would have anything like specifically insightful about it, but like besides that, like on like the bright side of things, like I guess I kind of underestimated the amount of people who will just like who will absorb something from what you're saying without necessarily like letting you know or uh, making you aware of it. That will just pass. Like there's people everywhere taking notes, that you'll never know about. And like a lot of that engagement is like that's the engagement that I want to maximize, but it's the invisible engagement. It's like I want people to try things that I'm like suggesting or proposing on their own, like, and I want them to be like, hey, so I tried this thing that you mentioned and it didn't work for me. Like there's at one point where I recently met up someone who like pointed that out to me, and I was like, oh, this would have been interesting information for me to know. Like it would have helped like build my intuition a little bit here. It's like I think there's a lot of value in sharing, even if you're not getting like immediate feedback. Like I think whenever I was starting to do this, that was basically the case. But quickly, as I started developing like real intuitions and became sufficiently motivated to, I guess, execute on actual research plans, people started paying more attention. And
Yeah.
yeah,
Interesting. And as per the days passing, it getting interesting and interesting as it goes by. And yeah, and I guess pretty much hot space to talk about. I guess we are pretty much to the end of the pod. At the very end, if you want to give some kind of advice or suggestions or your own takes, people starting at college or high school or who are just in the dilemma of what exactly need to be done to hop into the current AI space or the way it is forwarding, people talking about different architectures, thinking on the code levels. So yeah, what's the general take on that? If you have to say to them, yeah.
I would say if I had to give something concrete, there was a time in my life where I was like like pretty directionless and didn't really know what I was going to be doing, like in terms of like financial, like I don't know like what I'm going to be doing full time. And eventually, one of the things that I tried stuck because it gave me the right incentives to build something that I thought was really meaningful. So I think something that like stuck out to me is like you think and it feels it might feel in some ways like, oh man, I don't know if I'm ever going to like really find what I really want to do, or or if I'm even like sufficiently competent to develop the skills in something that like I think I could be good at. There's a lot of uncertainty that comes from just like being in an area where it's like liminal. You don't know which direction to pursue, but like eventually one of those random walks, you're going to start like staying on your 2 feet. You're going to stand upright. You're not going to fall over for the first time at something that is rewarding, and you're going to be able to pursue that path if you're relentless about it and you try, you make an active effort. And I don't know, it just sounds cliche whenever I say it like that, but the main thing that I'm trying to communicate is like you always feel like you're never going to get there, and then after just some time, because this has to happen over like the course of like weeks or months or years even, but you can't see it from day to day. But the little changes persist, and you find the direction of what you're trying to accomplish, and you become more competent at that. And it might not feel like you actually know what you're going to be doing or what you're good at, but the whole point of exploring is to find the direction and to pursue that direction. And there's plenty of time to do that, even if you're like just not sure for years, like what your life path is going to look like. Things can diverge at any point, either for the worse or for the better. But you're in control for most of your decisions that you make, and there's a large space of things that you can try to become competent at. And don't let that uncertainty like dissuade you from at least trying, I say.
That's pretty much real. And I guess, yeah, I guess following a passion is one of the things people should try to focus more about. And yeah,
Yeah, well,
yeah,
more specifically, what I'm thinking of is like people who don't have a passion, who think that they can't have, like they think that they don't have one or they can't find one, or like that like it's like a search that they can't like find anything meaningful from. Eventually, you'll find something that sticks. I feel like there's something out there
yeah,
for everyone that wants to become competent at something, and there's always a way to derive meaning from that, I think. But yeah,
yeah, that totally makes sense. I guess, yeah. All right, that's a wrap. Kalo, thanks again for coming on Ground Zero. Yeah, there were some glitches in between, but yeah, I guess we were able to manage
yeah,
a very pretty much a good length of pod. It was a blast actually going through your story, your experiments, and the lore around Prime Intellect, well, and the general masses to people what should be taken into consideration about. Keep cooking, keep dropping those wild ideas on teapot, and we'll be watching where it
I
all
will.
goes. Yeah. For everyone listening, this was Ground Zero AI Talks. See you in the next one. Thank you. Thank you so much, Kalo.
All right.